Hi, I'm Ajith from FTC Team 21351. In this video, we will discuss why custom parts are important in FTC. We will learn how to create a simple custom part from scratch using sketches and extrudes. We will learn how to check the fit of the custom part with standard FTC components in an assembly. And we will learn how to export the custom part as an STL for 3D printing. Let's discuss when and why you should use a custom part. Custom parts are used when there are no off-the-shelf metal parts that will do the job. Let's take this example here. We have these two U-channels that we would like to mount at this angle. However, there is no metal brackets that GoBuilder makes that allows us to attach these brackets together at this angle. As a result, we need to create our own plastic 3D printed part that fits in between these two U-channels to hold these two U-channels in this position. Let's start by creating a part studio in context. I will select the origin of this assembly to be the origin of the new part studio. So just click on the origin and click the check mark. Right, I will hide the reference planes. So as I said before, we want a bracket that fits inside these two U channels. So I'm going to select this face right here to be our sketch plane. Using the Use and Project tool, I will project these four lines onto our sketch plane. And then using the Line tool, I'll bridge this gap right here. Using the Trim tool, I'll cut off this extra bit right here. And then using the 3-point arc tool, I'll make this part curved. All right. Now we want the bracket to mount to these four holes right here. So I will create a perpendicular line between these two parallel lines. You can use the sketch constraint perpendicular Shift L to ensure that this line is perpendicular, and that'll also allow you to drag it across these two parallel lines while keeping it perpendicular. Let's do the same for the other side. All right. Now let's set the distance for how far apart we want these two lines to be. So I will start with 22 millimeters. If you can adjust this number based on how big you want the bracket to be. All right. So the next step is to transfer over these mounting holes onto our bracket. So we'll use the Use and Project tool right here. Project these four circles onto our sketch, as well as on the other side. However, if we 3D print a hole with the exact same diameter as the metal U-channel, the hole will be pretty loose and the screw might strip the threads pretty easily within the part itself. So we want to create the plastic hole a little bit smaller so the screw has something to grip and form threads inside. The diameter of the Go Build a holes is 4 millimeters. So I like to do 3.5. I'll use the circle tool in the top left corner to create a 3.5 millimeter hole. We need to do this for all 8 holes. All right. Now we have our sketch. So we can select the faces we want to extrude now. I'm selecting the outer diameter of the sketches as the inner circle here is 3.5 and the outer circle is 4, but we want a 3.5 millimeter hole, so we need to select the surface too. All right, now that I have selected all the surfaces I want to extrude, I can use the extrude tool to extrude it up to the face right here. Perfect. All right, now I want to add some material here so that we just slide in the U channels. So I'll do that by creating a sketch on this side, projecting the surface onto the sketch, and just extruding that up to face. And on the other side, I can just project this surface that we already designed straight onto this face using the project tool. All right, now we have our custom part designed. Now that we have designed our custom part, let's ensure that fits within the assembly. So head over to the assembly and use the insert tool to insert the part we just designed. All right, now let's mate our custom part to design to the U channel. Let's use the fasten mate tool to mate this hole to the inside of this U channel, like that. Click the check mark to commit the mate. On this side, however, it isn't as simple. If we try to use the mate connector already on this edge, it's not aligned. It's not parallel to this edge right here. So we need to use a mate connector to realign this mate. So use the realign tool and select this face as the primary axis entity and this edge right here as the secondary axis entity. As you can see, that shifted and realigned the mate connector. Now we can mate it as normal. There we go. We have ensured that it fits within the assembly. Now let's learn how to export this part as a STL file so we can 3D print it. So it's pretty simple. Just right click on the part on the left toolbar here and click export. Here we can name the part and change the format from step to STL and change the units to millimeter, the resolution to fine, and click the export button. As you can see, it downloaded our file. And now we can just open it into our slicer of choice and 3D print it from here. Thanks for watching the video. In our next video, we will discuss more advanced custom part design.